All right, we're going to start with the 4-3 warm up. So I said it, but I'll repeat it. Like a question in 1 and 2 would be on the non-calculator portion of your quiz, and then 3. Actually, 3 can be done without it, but most of those word problems don't have a 30 or 40, a 30 or 45 or 60 angle. So that would be on the part that does have a calculator. So when we start with 1, it wants the cosine of theta. Theta is in this bottom corner. Adjacent to it would be 3, but the hypotenuse is c, which means we've got to find that first. And how do we find the missing side of a right triangle? Good. So I'm going to do 1 squared plus 3 squared equals c squared. 1 plus 9. C is the square root of 10. So cosine would be 3 over root 10, but you cannot leave it with a square root in the denominator. So we rationalize by multiplying square root 10 on top and bottom. And you get 3 square root 10 over 10. So you'll never leave an unrationalized fraction in here, okay? If you did leave that on the quiz, you would lose the point. So be really, really careful. It's the same as like a simplified fraction. It has to happen. All right, for 2, it says find the cotangent of 45. There are 2 ways to do this. One is using your unit circle. So you'll fill that out first on your quiz. But if you know 45 is the pi over 4 angle, and every over 4 is root 2 over 2, root 2 over 2, and the tangent is 1, then I can simply take the tangent, flip it. The reciprocal of 1 is still 1. The other way to do it is set yourself up a 45, 45, 90 triangle where the side lengths are 1, 1, and root 2. 45 could be in either of these corners. Cotangents, the reciprocal of tangent, which is opposite over adjacent. So cotangent's adjacent over opposite. And you'd get 1 over 1, which is still 1. So it doesn't matter which way you do it. If you're a right triangle person or if you're a unit circle person, you should have gotten 1. Then 3 says, find the height of a tree if the length of a shadow is 50 feet with the sun at a 30-degree angle. So again, the picture's drawn, and again, I want to remind you it won't happen on your quiz. You'll have to draw those pictures. So this time, that 30 degrees means you can actually do this problem using your 30, 60, 90 ratio. So if we were to do that, and this was 30, and this was 60, this would be my A, this would be my A root 3, and this would be my 2A. The side you're given is this side, the A root 3 side. So A would be 50 over the square root of 3, or 50 square root 3 over 3. That's if you didn't have a calculator. The word problems, you will. So if I was to have a calculator, or mostly because this angle will not be a special angle, then in respect to the 30, H is where? Opposite, and 50 is? Adjacent. Which trig function is that? Tan. Good. So tan of 30 equals H over 50. And then I'd multiply. I'm going to take the AirPod out. I can literally hear it from here. 50 tan 30. And you get, I'm in radians. Let me go to degrees. Mode, degrees, 50 tan 30. And I get 28.86, so 28.9 feet. How do we do? Raise your hand if you got them all right. Okay, good. Questions? All right, so we're going to jump into 4-4. Most of this stuff is not on your quiz. Obviously, it's on the test, which is the week after next, but I can't wait to do it. So this homework will be due on Monday. My recommendation is to do the quiz review tonight, and then tomorrow, unfortunately, like usually when you go home from a quiz, you don't have homework. You will have the 4-4 homework, okay? So I'll open them both so that you can start it if you want to, but this will be due on Monday. It starts with a review of what we've been doing, though, so that's the good news. So all of this is the same we've already been doing. When I have a triangle, okay, built into a circle, I can find the sine by doing y over r, which is the radius or the hypotenuse. Cosine is x over r, tangent's y over x. Cosecant, secant, and cotangent are their reciprocals. The difference is in a unit circle, my r is 1. So all of those just become y, x, and then y over x. None of this is new. What's going to happen now is we're going to start to move into all different quadrants in this circle, okay? So I'm going to teach you a couple different ways. Well, not a couple different. I'll teach you really 2 ways to find things that are no longer in your first quadrant, like a coterminal angle, that kind of thing. But as a refresher, because you're going to have to fill this out on tomorrow's quiz, are zeros on the right, 0 degrees and 0 radians. At the top, 90 and pi over 2. On the left, 180 and pi. On the bottom, 270 and 3 pi over 2. And then we even added on 360 and 2 pi. So the one that you already filled out, your blank unit circle that you filled out, you're getting exactly that circle back. That's what's on the, I copied it on the back side of your quiz. So it is that exact one. So you know exactly what it looks like, okay? Then goes your angles. What's the pattern for your degrees? 30, 15, 15, 30. So you should be able to go all the way around your circle with that. Then comes the radian angles. The ones closest to your x-axis are your over 6s. Closest to the y-axis are your over 3s. In between are your over 4s. In the first quadrant, we leave pi alone in the top. In the second quadrant, it's 1 less than the denominator. In the third quadrant, it's 1 more than the denominator. In the fourth quadrant, it is 1 less than double, or 5, 7, 11 if you memorize that. Then you've got to go around and fill in all of your coordinate points. So every over 6 has the coordinate point that is root 3 over 2 and 1/2 with a tangent of root 3 over 3. Every over 4 has a coordinate point of root 2 over 2 and root 2 over 2 with a tangent of 1. And every over 3 has a coordinate point of 1/2 and root 3 over 2 with a tangent of root 3. And then obviously the signs change as you move around, and we know the signs because we know the acronym. All students take calculus. So in the first quadrant, all of them are positive. In the second quadrant, sine and cosecant are positive, everything else is negative. In the third quadrant, tangent and cotangent are positive, everything else is negative. And in the fourth quadrant, cosine and secant are positive, everything else is negative. And then the coordinate points right, left, up, and down. This would be 1, 0 because you're going to the right one. This would be 0, 1 because you're going up 1. This would be negative 1, 0 because you're going back 1. And this would be 0, negative 1 because you're going down 1. So again, 30 points goes to that. Make sure you know how to fill that in because once you get that filled in, then you can use it for the other stuff. On the right is just your negatives. So remember, negatives go clockwise, or you can find it where it's positive and fold it like a hamburger, and where it overlaps is where it's negative. So you get to choose.
Do you have to draw angles tomorrow?
Like the radian ones?
Yeah.
No. Okay. So these are your quadrant angles. If you think about it, you could have hopefully filled these out just knowing that this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. The first one is at 0. So at 0, your sine being the y there would be 0. Your cosine being the x there is 1. And your tangent is the y over x, which is 0. Tangent here is 0. Tangent here is 0. Tangent here is undefined. Tangent here is undefined. So at 90 degrees or pi over 2, my y is 1, my x is 0, my tangent's undefined. Here at 180 on the left, my y is, or sorry, not on the left, on the bottom, my y is, no, I did go left. My y is 0, which is my sine. My x is negative 1, which is my cosine, and the tangent is 0. And then the last one, 270, which is at the bottom. Your y is negative 1. Your cosine is 0 because that's the x, and your tangent's undefined. These cannot be found with your right triangles. So the quadrant angles, you can't set up a right triangle because there's no way to find tangent of 90 degrees because opposite is the same thing as hypotenuse. It's impossible to find them. You have to know your quadrant angles. Anybody still filling it out? All right, so now what happens if our radius is not 1? You will get a coordinate point, and you will see that those coordinates are not unit circle based. There's no root 2 over 2. There's no 1/2. There's no root 3 over 2. That's how you know that this is, okay, I have to set up a triangle. So A says, or the directions say, determine the exact values of the 6 trig functions of each angle. So I'm going to close in this triangle. If 4, 3 is my coordinate, that means the x is 4 and the y is 3. Do you remember this triple? What's your hypotenuse? 5. 3, 4, 5 is one of your triples. 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17. Those would be the most popular ones. They're not the only ones, but those are the most popular. So now given that, it wants you to find all 6. So the sine of theta is opposite over hypotenuse, 3 over 5. Cosine of theta is adjacent over hypotenuse, 4 over 5. Tangent of theta is opposite over adjacent, 3 over 4. Then we flip them to get the rest. So cosecant, 5 over 3. Secant, 5 over 4. Cotangent, 4 over 3. Questions so far? Now go to B. The terminal side of your angle is actually in the second quadrant, but we can't make a right triangle going that way. So we make a right triangle always with the x-axis. So I put theta in the corner between the terminal side and your x-axis. It always goes there. It doesn't matter which quadrant you're in. The change in x is now a -8. The change in y is a +15. We moved left and we moved up. Now the hypotenuse, or your r, will always be positive. So even if there's a negative or a positive on the other two, the radius is always positive. And what did we just say is the third side for an 8, 15 triangle? 17. So the sine is 15 over 17. The cosine is -8 over 17. The tangent is 15 over -8. That negative can go out front in the bottom or with the top, it doesn't matter. And then we flip them to get the reciprocals. 17 over 15, -17 over 8, -8 over 15. Joey. It always goes from the x-axis to the terminal angle. So we're using what's called a reference angle, which we're going to learn more about, and we did talk about in Algebra 2, but we haven't talked about it yet this year. But that's basically a reference angle. But your right triangle has to be formed with the x-axis. So I can't like put it here. I can't make that the right triangle. You have to form it with the x-axis. All right, example 2 just takes it one step further because it doesn't give you the diagram yet. The point is on the terminal side of the angle in standard position. Determine the exact values of the 6 trig functions. So if I have a coordinate point at -4, 7, that means I'm moving left 4, I'm moving up 7. So my theta goes there. Is there a triple with 4 and 7? No. So how do we find that third side? Pythagorean theorem. -4 squared plus 7 squared equals c squared or x squared. Call it what you want. R squared. 16 plus 49. 65. So c is, and again, normally it'd be plus and minus, but our radius is always positive. Positive square root 65, which is 5 and 13. Does not reduce. So it stays as square root 65. So my sine, 7 over square root 65, which is 7 root 65 over 65. Cosine negative 4 over root 65, which becomes negative 4 square root 65 over 65. Tan negative 7 over 4. Then we do the reciprocal functions, and remember those we want to flip before we rationalized. So my cosecant theta, I'm going back to this step, which would be square root 65 over 7. Secant, I'm going back to this step, which would be negative square root 65 over 4. And cotangent, negative 4 over 7. Questions on that one? All right, I'm not going to work all the way through B, but let's talk about what it looks like. This time we're going forward 3 and down 4. I close this in and I put theta from where I just closed it in as the radius to the x-axis. So again, it's always the angle formed by the terminal side and the x-axis. That missing side would be 5, and then you can find all your trig functions. Good so far? All right, this we have also already talked about. So the all students take calculus is also there's like one about snakes, which I hate snakes, so I don't even talk about it. Okay, and a smart trig class. Like they are all just acronyms to help you remember that. Those are the trig functions of the original 3 that are in that quadrant that are positive. Nothing new here. Example 3 is application of it. It says, name the quadrant in which theta lies if cotangent of theta is greater than 0 and sine of theta is less than 0. So what positive or negative sign does cotangent have if it has to be greater than 0? Positive. What sign does sine have if it's less than 0? Negative. So if we think about our trig functions, now these are our originals. So instead of we're looking at tangent or cotangent, we're looking at tangent because they would have the same sign. They would be reciprocals, but they have the same sign. So tangent is positive in the first quadrant and the third quadrant, which would be where cotangent is also positive. But from there, which of those has a sign that's negative? The third quadrant. So this answer is just quadrant 3. Sometimes there's more than one quadrant that could answer it. But this one, it's a both. It has to be both. Still with me? Yes? Questions? All right. Again, I'm not going to work all the way through this, but we will set it up. Because the only difference here is the delivery of the information. It says, given that the cotangent of theta is negative 4/3 and sine is greater than 1, find the following. So first of all, if I was to draw this in a circle, in a quadrant, if cotangent is negative, what 2 quadrants can I draw this in? The second and the fourth, right? Those are the 2 that cotangent can be negative. And this is why the second piece of information is given. Sine has to be positive. Which of those has a positive sign? Only the second quadrant, which means this negative 4/3, which could be a negative 4 over a positive 3 or a positive 4 over a negative 3, represents the adjacent side and the opposite side because it's cotangent. In the second quadrant, I move left and up. So which of the sides is going to be negative? The adjacent side is going to be negative, right? Because I'm moving left. So this is my negative 4, and this is my positive 3. If you want to flip it so you get opposite over adjacent is 3/4, that's fine. Put your values on there, but then use the logic of the location to figure out which one's positive and which one's negative. Now what's the third side? 5. Can we go from there? Can you guys go from there? Sine, cosine, tangent. Yes, right? We don't need to go all the way through it. All right, example 5 is now given in a different type of information. It says the terminal side of theta lies on the given line in the specific quadrant. Find the values of the 6 trig functions by finding a point on the line. This is an equation, yes, of a line, y equals 3x. How would I graph that? Start at 0 because your b is 0. Then what?
Put a slope of 3.
Good. 1, 2, 3 over 1. So what's that coordinate point?
3, 1.
Other way around, right? 1,
3.
3. Now, can I close it in? And can I put theta here? And I just made it a right triangle. So the x is 1, the y is 3. I'd have to use the Pythagorean theorem, which we already did this one once, to find the hypotenuse. And then you'd find your 6 trig functions from there. So the slope is your rise over your run, or the slope, which was 3 over 1 this time, is my y over my x. If it doesn't give you the quadrant, you're in quadrant 1. If it said specifically quadrant 4, then I would know, quadrant 3, I would know I'd be trying to use different positive, negative signs. Questions? Could you go from there? Do you need me to work that through? Do you need me to work that through? No. Okay, good. All right. This could be totally a quiz question tomorrow. This too should be over there. So cotangent of 3 pi over 2. Is yours fixed? Yes. Okay. It says evaluate the trig function of the quadrant angle if possible. So the sign at pi, where's pi? The 180 on the left, right? What's the coordinate point there? Negative 1, 0. What's the sign? 0. Cotangent 3 pi over 2. Where's 3 pi over 2? The bottom. The coordinate point there? 0, negative 1. My tangent there is what? Undefined. So the cotangent would be? 0. So again, those are the kind you cannot use a right triangle for. You have to use your quadrant angles. Still good? All right, here's your reference angle. So a reference angle of theta is the acute angle theta prime. We refer to that little apostrophe as prime, formed by the terminal side of theta and again the horizontal axis. So the same place that we've been putting our thetas, which is on the x-axis, those are called reference angles. To find the reference angle, you literally find the difference between the angle and the x-axis. For your general over 3s, over 6s, and over 4s, that is your reference angle. So if I said here, 5 pi over 6, and I wanted to find, this would be my reference angle, it is pi over 6. And that's why we put theta there. If I put it here, and this is 7 pi over 6, if I did 7 pi over 6, or the distance from 7 pi over 6 to here, which is pi, it would be pi over 6, which is why that reference angle is still pi over 6, okay? And the same thing over here at 11 pi over 6, I would do the distance between these, which would be 2 pi minus 11 pi over 6, which is still pi over 6. So all the over 6s, all the over 4s, and all the over 3s, the reference angle is literally pi over that. If it's something other than that, if it said pi over, let's say it said 5 pi over 7, now you have to figure out what quadrant is that in and what's the distance to the x-axis from there. And that's when it's important to understand this is 0. At the top is 1/2 pi. On the left is 1 pi. And on the bottom is 1 1/2 pi. Now, and this is 2 pi. Now you already know that. But if I said, where is 4 pi over 7? How are you going to find it? You can, well, you can, but then it will be negative. That just gives you coterminal. So if I wanted to find it and it wasn't a special angle, the goal is to figure out, ignore the pi, and look at the fraction. And does that fraction fall between 0 and 1/2, 1/2 and 1, 1 and 1/2, or 1 1/2 and 2? So 4/7 falls in which of those ranges? It's in between 1/2 and 1. Does that make sense? What would be 1/2 of 7? 3.5 over 7 would be at the half mark, right? And 4 is just a little bit bigger than that, so it puts it here. So that's in the second quadrant. Everything is relative by the half pies. And if I wanted to know what the reference angle is, I would do pi minus 4 pi over 7. That's how you find the reference angle if it's not a special angle. Figure out what quadrant it's in, and then take that angle and find the distance from it to the x-axis. All right. Find the reference angle, theta prime, and sketch theta and theta prime in the standard position. What's the reference angle to 2 pi over 3? Pi over 3. So if I wanted you to sketch both, pi over 3, first quadrant, 2 pi over 3, second quadrant. Your reference angle should always be in the first quadrant because it's always going to be pi over 2 or less than pi over 2. How about 9 pi over 2? What's the reference angle? Pi over 2. Where's pi over 2? On the y-axis. This is pi over 2. Where is 9 pi over 2? How do I find it? You can keep subtracting 2 pi, but you got to pay attention how many times you do it because that's how many times you got to go around. Or what do I do with 9 over 2? So 9 over 2 is what in mixed number? 4 and 1/2. Where's 4? On the right. I went around 2 pi. I went around 4 pi, and now I go 1/2 more. So this angle looks the same, except you go around more times. All right, again, quiz question. Find the sine, cosine, and tangent of the angle without a calculator. So let's think about the 2 ways you could do it. One is 5 pi over 4 on your unit circle. Yes, if you drew out your unit circle, it's already there. What's the coordinate point at 5 pi over 4? Negative root 2 over 2. And negative root 2 over 2. And what's your tan? 1. You already found all 3. The other way to do it, if it wasn't on your unit circle, is take 5 over 4, convert it to a mixed number. What's that in a mixed number form? 1 and 1/4. Where does 1 live? 1 pi. On the left. Is 1/4 less than a half? Or is it bigger than a half? Less than a half, so I stop at the over 4 in that first one. So you can do this with any number of any size, as long as the reference angle is one of your over 4s, over 3s, over 2s, over 6s. Yeah.
What should we do with the number you give us? Is it on the unit circle or is it always going to be?
It's not always going to be on your unit circle. Yeah, especially because I'm giving you you're filling in the unit circle tomorrow. It will be an application. So it could be something like negative pi over 5 pi over 4. So it's that one is there, but it would be the negative one, which means it goes into the second quadrant. That you could see. Hang on. We do this. This is a quiz question. Can you do this? How? Calculator. What mode would A be? Radians. And I would do 1 over the tan of 4.3. So this could be quiz question. 1, making sure I'm in radians. 1 divided by the tan of 4.3. And I get 0.4375 if it's set to round to 4 decimal places like it did. And then secant of 213 would be what? 1 over cosine of 213 degrees, which means I'm switching back to degrees. 1 divided by cosine 213. And I get negative 1.1924. Okay, remember you could also get your degree minute second notation. That is on your quiz review. Yeah.
So if there's no degree sign, it's always radians?
Correct. Whether or not it has a pi. Yep. All right, it says the displacement from equilibrium of an oscillating weight suspended by a spring is given by, and it gives you this equation. An oscillating weight is something that goes up. So it's a spring. Like if you think about a spring, right? A spring is like a curly thing, right? It's hanging. And there's a weight on the bottom. And somebody pulls it. It's going down and up and down and up and down and up. And it creates a sine curve. You remember your sine curves? Up and down and up and down and up and down. That's for 5 people. That's Monday. Okay, so graphs of sine and cosine are Monday. Yay. Huh? All right, so it's creating that sine curve, which you don't need to know how it was created. They gave it to you. What you do need to know is how to type that into a calculator, because all it says is find the displacement when A, t is 0, B, t is 1/4, and C, t is 1/2. So I'm literally going to type in the calculator 2 sine of 6 times 0. Then I'm going to do 2 times the sine of 6 times 1/4. And then I'm going to do 2 times the sine of 6 times 1/2. Because that's here. What mode should you be in?
Radians.
Radians. Unless it said degrees, it needs to be radians.
So unless it specifically has the degree symbol, it's a radian.
Correct.
Okay, that's cake. I love this.
So,
0 outside the parentheses?
the 0 is going to get multiplied by the 6.
Okay.
Yep. So it'd be like if it was in parentheses.
Together.
Correct. So I do 2 sine 6 times 0, and I get 0, because the sine of 0 is what? Where's 0? At 0. What's the coordinate point there? 1, 0. What's the sign there? 0. So this whole thing is really just 0. 2 times 0 would give you 0. You don't even need your calculator for that. No. 2 times the sine of 6 times 1/4 is 1.99498. So actually that rounds to 50. And 2 times the sine of 6 times 1/2 is 0.2822. So there is a question like this on your test, because that's the application of an equation, but not on your quiz. Questions? So in addition to this kind of stuff, you will be doing your unit circle. So basically everything that's on this front page is without a calculator. On the back side, I put your unit circle. You could fill it in whichever order you want, but obviously I would fill in the unit circle first because you could use it to answer some of this stuff. Then comes the stuff that's with the calculator, which doesn't start until after the 30, 60, 90 triangles and the 45, 45, 90 triangles. So this is still no calculator. You have to set up your ratios, your 45, which is the A root 2, and your 30, 60, 90, which is the 1, or A, root 3, and 2, A. And then everything down here is calculator based, okay? There is one without a picture, so hopefully that gives you a little bit of practice. And then there's some calculator practice on the other stuff that we literally just did. Make sure you know how to do your degree, minute, second notation, all that stuff.